Now what I can also do is that, remember that earlier on I showed you the is now function, where you can actually use to find if there are any null values in there. In this case, when we check, there were no null values in here. So I'm going to create new data sets, right? I'm going to create in new data set and then manually put some null values in there, right? Manually I'm going to put some null values in there. So if you see this one, I'm using the pd.dataframe, right? So pd.dataframe will actually help you to create a data frame. Then inside the pd.dataframe function, remember that is a function, right? Then inside that, I'm going to use a dictionary, right, with this curly bracket. So if I do that, then I convert this dictionary into a data frame, right? So after I create the dictionary and then I pass it inside the data frame function, it's actually going to give me this form of a data frame. Okay, it's actually going to do that. Now if we check for is now, right, you see that it's giving us true or false, just like we were seeing in the big data set that we were actually dealing with, right? So that's actually will give us that's actually going to give us what we were actually dealing with earlier on. So let's go all the way down here and then see over here. So we are going to use the same is null to actually identify if there are any null values in here. And then is na, you can also, I told you can use either is null or is na. See that they are all giving me the same boolean output, that is true or false, right? I told you, in order to save yourself, you can actually count how many truths that you have in there by using the .sum function, right? So if we do that, you see that at the column value 1, right, at the column value 1 we have 2 null values in there, as you can see, two truths in there. And then at value 2 we have 2 of them, right? The value 2, we have 2 of the truths, right? So true represent null value, right? If you see the original data set, you can see that we have NaN. Remember that I told you that NumPy sees null values as NaN. Okay, so we see that where I encountered NaN, it actually put the true, right? This one true, this one false and false, right? False and false, and then the rest here, true and true, and then the rest here are all false. Okay, now we can use the isNA function to perform the same thing as I showed you. So if you use the sum, it actually summarizes everything. It counts all the truths and then summarizes it for you. Okay, now what we can do is that to replace these NaN values, and you're going to do this over and over again during your project classes. You're going to be doing this over and over again, where you need to actually take care of all these NaNs. These NaNs, right? You need to take care of them. So there are several ways that you can actually do, right? You can either drop these NaNs, right? You can drop them. Remember that earlier on I told you, if you drop any value, any column or any row, you actually losing a significant information. Okay, you actually losing a significant information, so you need to work your way around it instead of dropping it. Okay, one way that you can do is to use this fill NA function. Okay, use this fill NA function. So in this case, I'm going to fill the NA with what? With the mean, right? So with the null values that are present, I'm going to fill it with the mean. Okay, and I'm using in place equals true to indicate that what I'm going to actually do is located in the whatever changes that I'm doing here should reflect in the original data set. So that's what I'm going to use this in place equals true over here. Okay, so if I do that, right, if I do that now, in subsequent videos I'm going to show you why we are using the mean over here. Okay, I'm going to show you that you can either use the mean, the median, or the mode, right? So if you take a data set where the data is quite skewed, right, then the mean will not actually be the best option for you, right? If it is normal distribution, normally distributed, then you can actually go ahead with that. We are going to discuss this in the subsequent videos, so don't worry yourself about it. What I want to show you over here is that you can actually replace these NaNs, right? These these null values, right, and not a number, right, we can actually deal with it instead of dropping them. For instance, if we drop the whole column here, we lose this 121.0, we lose it, we lose VU, VYU, we lose that one too. We don't want to do that, right? And in the same way, if we drop, say, if we say that there are two NANs, right, or null values in here, so we're going to drop the column value too. Don't forget, we are also dropping 300 and then 121, right? We are going to drop that. We don't want to do that. So what we want to do is to work our way around, and one way to do that is to use the fill NA function to actually fill it with something. In this case, we are going to fill it with the mean of the column. So to calculate the mean of this the mean of this column, right? So in this case, the mean of 100 plus 234 divided by 4, right? That's 1 2 3 4. So if the total point is 4, then it's actually going to calculate the mean of that and then replace these NANs with that mean. Okay, that's what this fill NA is actually going to do for us. So over here you see that we don't have NAN again. The NAN, there were one NAN over here, there were another one here, so the mean of 100 and then 234 is actually 167. So all the NANs will be replaced with 167. In the same way, the mean of this column, right? So we're having two NANs over here. This is this and then that, right? This one and then that one. So we will find the mean of this and then replace each of these with that mean, and that's what actually is happening. The mean of this column, which is 301 to the 1, is actually 210. So all the NAN will be replaced with 210. Okay, so that's another way that you can actually deal with it. Okay, and then you can actually find the mean of each of them, right? If you want to see the mean of them manually and then confirm. So we see that the mean of this column, which is value 2, is actually 210. So you can see that 210.5 is actually being used to replace these NANs, right? And the mean of this column was actually 167. So that's why you can see 167 appearing. So wherever it will encounter NAN, the fill function is actually going to do that for us. Okay, now we can also use this sort values, right, and then specify how we want to actually sort it. That is sorting it from smallest to big, largest, or from largest to smallest, right? So if you have your data set and you want to rearrange it into maybe the largest to the smallest, then you can use sort, right? You can use either ascending equals true or ascending equals false to do that, right? To sort your values, right? You can use the sort values functions to do that, and then you manipulate this ascending equals true or ascending equals false. Either of them will work based on the requirement that you need. Okay, so over here what we're going to do is to use this sort values, the same thing that I did here. So at first I use ascending equals true, and now I'm going to use ascending equals false. Now let's see the difference between these two. Okay, let's see the difference between these two. Now when I use sort values, then I say that sorted by value 2. So I'm saying that sorted by value 2 column. So it's actually going to arrange the numbers in the value 2 column. Okay, so it's going to rearrange everything in the table according to the value 2 column. So I'm saying that ascending equals true, meaning that start from the smallest to the largest. So you can see that 121, 210, 210.5, then 300. So keep on increasing, right? It will keep on increasing. Okay, it will keep on increasing. So if I use ascending equals true, meaning that start from the smallest, right? Start from the smallest, then increase it, right? Then increase it for us. So I'm going to sort the whole data according to value 2, right? I can do the same thing, right? I can sort it by price. So I can over here I'm using my original data, right? My original data, which we loaded into our data frame over here. This one is the one that we'll be working with, right? So this is the original data, and I'm going to do that, right? I'm using the sort of value on that, and I'm sorting everything by price. So if you go over there and then see, right, I'm going to sort everything by this price, right? And I'm sorting it saying that Let's go all the way down, showing that the ascending order should be false, meaning that start from the largest to the smallest. Instead of here, I said ascending equals true, meaning that start from the smallest to the largest. So I'm going to do the same thing, but in this case, what I'm going to specify is that it should specify that it should start from the highest to the smallest, right? That is with respect to the price column. Okay, if we do that, right, let's go and see the price column. You can see that we have 45,400. That was the largest value or price that we have on the price column. So you can see the next one is 41.315. So they keep on reducing, right? 40,960, 37,028. So we keep on, it has actually ordered them according to the highest, right? According to the highest. You can also use the group by, right? So if we use the data.group by the fuel type, right? So the fuel type is either is gas or is let's see how many the types that we have, right? Is either gas or is diesel, right? Is either gas or diesel. So if we use group by and then we specify group by which column, right? We want to group by the fuel type column, so it will group it according to this way. So group it according to the type that you can actually the type of values or data point that you can find in that column. Okay, so that's what is actually happening over here. Then over here, maybe I want to just count, right? I want to count the total number of cars that I have in the make column, right? In the make column, in our data set is what is containing the cars, right? So if you go a little bit up, so the make column contains the various types of cars, right? If I want to count, say maybe how many BMWs do I have here, how many Audi cars do I have here, right? So I can do that by using the count function. Okay, I can do that by using the count function. So let's go all the way down, right? I can do that using the count function. Okay, so if we do that, right, you see that we have 201, right, total cars that we have, right? So in this case, it's actually counting this. Let's go here to the make, right? It's counting how many cars in total do we have, right? How many cars in total do we have? If we want to see individually how many Volvo cars, how many BMW cars, how many how many Porsche cars do we have, how many Mercedes Benz do we have? If we want to do that, right, individually, then we can use the value count. So if I show you here, we can use this value count to actually count the various types of cars that we have and how many do we have. So in Toyota we have 32 cars, right? 32 cars that we have in our data set, right? And then Nissan is having actually 18, right? Mazda is having 17, Mitsubishi is having 13, Honda 13, Volkswagen 12, right? So we have 12 Volkswagens in there, right? Honda, we have 13 Hondas, right, that we have in there. Okay, so we can actually use the value count to count individual items that we have here, and then we can use the count to count everything, right, that we have over there. All right, now what we can do is I think I've even explained this, like the difference between count and then the value count. I've even explained that, so there's no need to taking it as an assignment, but you can still read about that. Okay, now let's see how we can perform some concatenations, right? Let's see how we can perform some concatenations over here, right? So this is a dictionary that we've created, right? So we've created our dictionary with this key and then these values, right, in there. Okay, and then if we store everything here, so if we see what is inside here now, if we can convert this, right, you can convert this dictionary to a data frame using just the data frame, right, using just the data frame, then passing this stars that we have. Okay, now if we do that, right, we store everything in M1, right? We store everything in M1 after converting this this data frame into a pandas library. We store everything in M1. Okay, we store everything there. Now if we see over here, this is what we have, right? You see this is more readable as compared to this, where we have 1, then this one are there letter, and then we have this, but this one is more readable in the form of a tabular form, right? So that's what pandas will actually help us to actually achieve. Okay, if you see that one at one we have 2 3 1 4 5, so you see they have 2 3 1 4 5, so the same thing that we have over here, but just converted into a data frame. Okay, okay, let me open this one so that we can work with. Okay. Okay, so this is our DF, right? So remember that we've been working with our DF earlier on, right? So our DF contains these items, right? So what I'm going to do is that I have also created this dictionary, right? And then I've converted this dictionary into a pandas data frame, right? I've converted that into a data frame, which I have this output, and this is my df. So what I'm going to do is that I'm going to combine these two, right? I'm going to concatenate this mm1 and then the df, right? That's just to put them together, right? That's what I'm going to do over here. Okay, now if you see what I'm doing here, right, I'm creating a new variable which is my new df, right? So my new df is actually going to contain the df that I have, right, which is this original df, and also it's going to contain this mm1, right? It also contain mm1. So in order for me to be able to put two data frames together, I'm going to use concat function. All right, so in pandas we have concat function there, which will help us to do that. Okay, so if I do that, right, if I do that, this is what is going to happen. This is what is going to happen. It's actually going to put one. Let me bring my pen so that I can actually show you what is actually happening over here. Okay, it's actually going to put let me do this. Okay, now what is happening here is that it's actually going to put one data frame, right, on top of the other, right? We're going to put one data frame on top of the other. So if you see the index, it starts from 0 1 2 3, and then it starts again 0 1 2 3, right, 4, right? Remember that our df, right, if I do this, our df here, right, our df is 0 1 2 3, right, which is this one, 0 1 2 3, because that's what we wrote at first, and then at last we wrote this mm1, which is 0 1 2 3 4, right? So that's what you have here, 0 1 2 3 4, right? So it will put one on top of the other, and then where we don't have points to actually put it there, right? When it's putting one on top of the other, where we don't have pointer to replace it with nan. Remember that we've been dealing with nan, right? That's the data point that is not available, right? Not a number, not a number, not a number, put it there. In the same way, so this one is actually specifying, so this column, right, this column is actually coming from the mm1, right? Is the mm1 which is having that column. If you see it here, it's having 1 2 and then letter. That's what you have here, 1 2 and letter. And then the df is having value 1 value 2 and value 3. That's what you have here, value 1 value 2 and value 3. Okay, so this one, the df, right, the df here is not having any of these, right? So it will be nan over there. In the same way, our mm1 is having this column, right, and it's having these values, so it's not having this column, and it's not having these values. All right, so it has stacked one on top of the other, right? So we have this df, right, we have this df, that is this one that I put here, on top of this, on top of the m1, which is this one that I put over there. Okay, so if I don't want to do that, right, I don't want to stack one on top of the other, but I want to stack them side by side. What if this one can be put here, right? What if it can be put here, and so that it will stand side by side, right? So I can do that, right? I can do that by using this, right, by specifying that the axis equals 1. That is concatenate them based on the column, but not based on the row, right? Not based on the row, as it has done here, but based on the column, right? So if I do that, right, if I do that, this is what I have. You see that now I have the 1 2 letter, right? It's now doing it this way. Let me zoom a little bit like this. Okay, let me do it like this. Now it's doing it this way, right? Is doing it this way and putting them side by side, right? So this one is here, so this, my df here is this one, right? So this is my df, and then my mm1 is this one, right? This is my mm1. Unlike this one where we have it like this, right? Where we have our, this becomes our df, and then this one becomes my mm1, right? So this one was this one was on top of this, right? So that's why we're having a lot of them, but I can put them side by side, right? I can put them side by side by just using this axis equals 1, right, to show that stack them according to the column but not according to the row. Okay, now we can also use join and then merge, right, just like you do in your SQL, right? So in Python too, we can also do join and then merge, right? We can do join and then merge in Python. Okay, so what I'm going to do over here is that I'm going to create two different dictionaries over here. I'm going to create two different dictionaries. One is called sales, one will be called region. Okay, so in sales I have my key here, which is Jones, which is the name of the people, and then the sales that they make, right, the name of the people, and then the sales that they make, right, the name of the person, the sales the person make, the name of the person, the sales the person make, right. And then if the region, right, that's the name of the person, and the region they make their sales, or the region they sell, right. And then here I'm using mp.nan, right. I'm intentionally generating nan, right, not a number, so there were no number to put here, so I'm going to intentionally generate this np.nan, right. So these are names of the people, the sales guys, and where they sell, right, and these are the names of the sales guys and the amount they sell, right. So these are the two different dictionaries that I've created. Okay, these are the two different dictionaries that I've created. Okay, if you come here, I'm going to convert these two, right, these two dictionaries into a data frame. Okay, so I'm going to use pd.dataframe, right, and then I'm going to convert from the dictionary to a data frame, right. So that's what I'm doing over here. I'm using the pd.dataframe.convert from dicts, right, which is dot from dictionary. I'm going to convert it. So it's sales. If I pick the sales, I'm actually going to convert it, right. I'm going to convert it from this dictionary to a data frame, right. That's what is actually happening over here. And then I'm specifying the columns, right, as you can also do that. And then the same thing I'm going to do for the region data. I'm going to specify that. I'm going to use the data frame to do that, and then I'm saying that from the dictionary type, convert it to a data frame for me. Okay, so I store everything. The sales data, I store it in a sales underscore df, right, which contains the data frame of the sales, and then the region underscore df, which contains the regions, that is the name of the people and their regions, all right, that they sell, right, which I have converted into a data frame. Now if I do that, right, this is what I have, right. This is what I have. Now I have sales, right. This is the sales df, that's the sales data that I've converted into a data frame, right. So I have the Jones, right. I have Jones, and then the sales that Jones make, which is 10,000, right. I have Chris makes 5,000 sales, Piyush makes 440, Mira makes 6,700, and then Rahul makes 300. Okay, so these are the data points that I have in my sales underscore df. Okay, then if I see the region underscore df, remember that I converted sales and I converted region. And so if I see the region underscore df, right, and see the data points that we have the names of the people and the region that they sell, right. Remember that I intentionally created some NaNs, right, which is this. So you can actually see them coming here. Okay, now I've done that, right. So now let's start. I told you that we're going to do join and then merge. So I wanted to have a data which I'm going to use for this join and then merge. So I've created my data over here. So now I'm going to use this data, right, which is the sales df, which I have it in this format, and then the region df, which I have it in this format. So I'm going to use this to perform the join and then the merge. All right, so let's see the join at first. All right, let's see the join at first. So if you see the diagram that we have here, right, so there are several ways that we can do the join, right? There are several ways that we can do. If you're familiar with SQL, I mean, it's just the same concept that we're going to use here, right? It's the same concept that we're going to use over here. So the inner join is nothing but what is common. Let's say this is A and then this is B, right? So A cell and then B cell, right? So what A cell contains, right, which is also in B cell contains the same thing. So what is common among A cell and then B cell? So let's say we have 1, 3, 4. Let's say A contains 1, 3, 4, and then 8, right? And then 8, or maybe I should do it over here. Maybe A contains 1, 3, 4, 8, right? And then say yeah, maybe up to 8 is okay. Okay, and then let's say our B. Let me put it here. Our B contains, say our B contains 2, right? Our B contains 2, 5, 9, 8, right? Something like that. So in this case, what is actually going to happen over here is that 8 is common between these two, between A and B. So that is going to be here, right? And whatever data point that is left, right? Whatever. So it's 8, actually 8, and then okay, this one is I think I put 4 there. So 8 and then 4, right? 8 and 4. So when we cancel this 4, okay. So 8 and then 4 is what is common between A and then B. So if we join according to inner join, then what is going to happen is that the data point that is common between these two, the ones that is going to output, right? That's what it's going to output. And if I use the left outer join, it means that if I have A, then I have B here, right? All the data points that are in the left side, that's in the left data point, that is A here, is actually going to appear, right? But only those data points that are present in B and also present in A, right, which is this point, right, which is this point, is actually going to happen, right? So I'm going to have virtually everything that belongs to A, right? That's everything that belongs to A, and anything that A and B are also having in common. So that will become the left join, right? And if we have A and B here and we want the right join, then everything that B contains, right, everything that B contains plus everything that B and A contains, right, plus everything that B and A contains, that becomes the right outer join. And if we do the full outer join, it means that we're putting both A and then B all together, right? We are putting both A and then B all together. So basically that is what is actually happening over here, right? That's what's actually happening over here. The inner join, the left outer join, the right outer join, and then the full outer join, right? So let's see how we can actually work with these joins. Okay, let's see how we can work with these joins. So over here, what I'm going to do is that, remember that I created my data that I want to use, right, which is sales DF and then region DF. So I'm going to use that data moving on. Okay, so see what I'm doing over here. I'm creating a variable called joint_df, right, which is a variable that is actually going to store whatever operation that I'm going to do here. So I used my region_df, right? I picked my region_df, which is nothing but this region_df, right? And then I say that dot join, right? Now I'm going to use join, right? Join sales df. So I'm going to join sales df and region df, right? But there's a condition that I need to give. How do I want to join this? I want to join this on left. That is the left outer join, right? That's left outer join. So this one, that's left outer join, which means that anything that is here, right, and also the things that are here and also here, right, the things that these two cells have together, plus the things that this one have only that this one is not having. Okay, so basically what I'm saying is that if we have these two cells, right, we have these two cells, the outer that I'm writing there is anything that, if this is A and B, anything that this B is having that this A is having that even B is not having, right, plus anything that A and B are all having together, right, which is here, right, all these is what is actually going to happen. So if I say how equals left, right, that's what is actually happening, and that's what I mean. Okay, so that's what is actually happening. So anything that is present in the region df will come, but only those that are present in sales DF and also present in region DF is going to be output for us, right? So if we see the result that we have here, right? If you see the results that we have here, if we see the region DF, right? The region DF is actually having this John, right? Let's see the names of the people: Jones, Chris, Piyush, Mira, Anthony, Ellen, Josh, Simran, Oscar, right? That's what we have over here, right? Jones, Chris, Piyush, Mira, Anthony, Ellen, Josh, Simran, Oscar. That's what we have over here. Now, if you see the sales, right? Sales is having Jones, Chris, Piyush, Mira, and then Rahul. But Rahul here, right? Rahul here is not part of this, right? So if we are doing the left join and we are joining it on this, right? We are using this one as the left data, right? Then everything in this left data will come, but only those that are in this sales, which is the right data, that are also present here will come. So Jones is here, Jones, Chris, and Chris is here, Piyush is here, Mira is here, but Rahul is not here. So Jones, Chris, Piyush, Mira will come, but Rahul will not come, right? Because we are using left outer join, and we are consider this as the left table. Okay, so everything on the left table will appear if you're using left, right? If you're using left outer join, which is this, then everything on the left table will appear, but only those that are present in sales data that are also present in region data that will appear. Okay, so those that are not available, you can see that there are some NA and being generated for them. Okay, we can also do writes, right? We can also do the write. And now if we do the write, it means that all the things that are present in sales DF are going to happen, are going to appear, but only those that are present in region DF and also present in sales DF that are going to have going to be added. Okay, so we are using write, and this is the write table, means that everything in write will appear, but only those that are in region and or those that are in left and also present in the right that are going to actually be output. Okay, so if you see over here, we have Jones, Chris, Piyush, Mira, and then Rahul. But if you see the region DF, remember that in this case we are saying that everything in sales DF will come, but not everything in region DF will come, right? It's only those things that are in region DF that are also in sales DF that will come. Okay, so that's what is actually happening over here. You can see that only Jones, Chris, Piyush, Mira, right? So here Anthony, Ellen, Josh, Simran, and Oscar will not come, right? They will not come. You see that they are not there. Okay, but Rahul, which was not part of which was not part of the regions DF, is coming because we are using right, and everything in sales DF is supposed to come. Okay, now since that one is done, we can also do the inner join, right? Inner join means just like you have a set and you're talking about the intersection of the set. That's everything that is present in region underscore DF and also present in sales underscore DF is the only thing that is going to happen, right? That's the only thing. So we have Jones, Chris, Piyush, and Mira, right? So if you see your original data set, right, if you want to see the things that are common to them, Jones, Chris, Piyush, and Mira, right? Jones, Chris, Piyush, and Mira. But Rahul is here, but not here. So Rahul will not come. In the same way, Anthony, Ellen, Josh, Simran, Oscar, they are here, but they are not here. So they will not come. If you consider inner join, right, they will not actually show. Okay. In the same way, we can do outer join, which is combining everything. So whether, all the data points in region DF will come, all the data points in sales DF will come. Okay. So you can actually use either of them, either inner or outer, or right or left, right? So they all depends on you. They all depends on what you want to achieve. Okay, so if you do that, you see that we have all of them put together. Okay, we have all of them put together. We can also do merge, and merge works the same way. Merge works the same way. If I show you the code here, over here, I'm just going to remember that in SQL you merge on a certain key, either the student ID or the employee ID or something like that. You merge on something like that. In this case, what I'm going to do is that if you see this, right, you see our data, the region DF, right, and then the sales DF that we're working with. We have sales over here, but the index, we don't have any column name for that. We don't have any column name for that, but that's where they have things in common, right? That's where they have things in common. So I want to merge on the things that they have in common. In order for me to merge in, if this is an employee data, then maybe this will be an employee ID, or if it is a student data, then this will be maybe the student roll number or the student ID, so that I can merge on the student ID. But these ones are the names, and they are the things that they have in common, right? But they don't have name that, I mean, a title or column name over here, which I can use to actually merge. That's what I'm going to do here, right? That I'm going to create column, I mean, index names for them, right? So for region df, I'm creating an index name for it. For sales df, I'm creating an index name for that. Okay, so if I print it out, now you can see that I have my region here, then I have names. That's what I created, right? I have names, so that later on I can merge on names. That's what they will be having in common. So that's what I can actually merge on, right? So for merge, you need to actually merge on something common, right? Unlike the join, where we can just join and then specify the condition as to how we want to join. But on merge, right, we need to actually specify, right? We need to actually specify, right, which column do they have in common that we can merge on. So if you see over here, I created the common names for each of these columns, because that's what they have in common. So names will be here as the title of this index, and then the same thing, names will be here as the title of this index. Now I can merge these two data sets on this common index name, right? So, or index title. So if I do this pd.merge, right? PD, forget about the printing first, because the printing is just printing everything that I'm doing. Remember that I said that make sure your code is as simple as possible. That's what I'm trying to do here, just to run everything on a single line. Otherwise I could have broke these things down. Okay, now I have pd.merge, right? So I'm going to merge the region df, right? And then the sales df, right? Now you see that, what are you merging on? I'm going to merge on the names. Okay, I'm going to merge on the names. You see how cute this is? Okay, now if I do that, right, if I merge them on the names, this is what I have, right? This is what I have Jones West, Jones sell at the West, right? And then the sales of John is around 10,000, right? Then Chris being second, right? The region of Chris is not actually available. That's why it is being put there as NAN, and then we have the sales to be 50. I mean the 5,000. That's for Chris actually, right? I'm talking about this one. That's for Chris. That's 5,000. And then if you see the Push right over here, Push sells most at the worst, and her sales is 440. The same way, Mirror's location was not actually identified. That's why we replaced NAN for that. And then we have 6,700, right? We have 6,700 sales. So I can easily do this to actually get an insight with the data that I'm working with. Okay, with the data that I'm working with. So well, earlier on I did merge, right? So I did merge on names, right? I did merge on names. So what I can also go and do is I can do this merge on left, right? On left, just like we're doing here on join, right? We have the left outer join, the inner join, the outer join, the right join, right? And then we also have the left. Okay, so the same thing that I'm doing over here. I'm doing how. The how should be left, which indicates that I want to merge, right? I want to merge on names, right? I want to merge on names, but I'm going to use left join. Left merge, right? So it's the concept of this left and the right here is just the same thing as we're doing in join, right? So if we do that, it means that anything that is present in region DF is supposed to come, but only those that are present in sales and also present in region DF are going to show, right? So we're going to do this based on the names, right? So you see that we have everything that is present in the region, right? But only those that are present in sales DF are going to come. So over here you can see that we don't have Rahul. Rahul was the one that is in sales DF and not in regions DF. So you see that we don't have that one over here. Okay, we can also do the same thing for say for right. So if we do that, it means that everything that is present in df is going to come. I mean, sales df is going to come, but only those that are present in region df are also going to come alongside. Okay, so just like we did it in the join, so you can see over here, although Rahul is not present in region df, but it's here because it's actually considering anything that is all things that are present in sales df, right? And then only those that are in region df that are also in sales df are going to be present. Okay, and this is the inner join where you can actually have the region df and the sales df meshed together based on the names, right? And also check that they are merging only on the things that are common to both of them, right? That are common to both of them. So that's why you have this kind of output. Okay, now we can also do this full outer join. That's like just like we did for this, right? You can also do that, right? For full join you can also do that. Okay, just like we did it for this. Now if I go all the way down here, right? If I go all the way down here, that's what I'm actually doing, right? The how should be outer, right? And then I'm merging on the names. So you can actually do this, I mean, in either in join or in merge. You can do them. Just that in merge you need to actually specify on what are you merging, on what are you merging. That's the only difference that you can actually find over here. So if we do that, you can see that we have everything put together because we are doing outer, right? So outer is more like everything put together. Okay, it's just like the union of a set. If you can think of it that way, you can think of it as a union of a set. Okay, so basically that's it. Everything that you're actually going to need in our subsequent classes, we've discussed them. Okay, so keep on practicing, and we're going to meet in the next class for we're going to meet in this next class for data visualization using Matplotlib and Seaborn. All right, so see you in the next video. Have a nice day.